Hello dear students, welcome to Karna Maths Academy. Today in this video we are going to discuss one of the most important vector theorems of optional mathematics SEE examination. Dear students, in this question we are going to discuss the proof of one of the vector theorem which is related to parallelogram. Dear students, this question is from CDC model questions SE examination, question number 24. So let's go to the question number 24, vector theorem of SE examination. Dear students, this is one of the most important question which is frequently asked in SE examination. So let's go to the proof of the vector theorem, question number 24. In question number 24, the question is prove by vector method that the diagonals of a parallelogram bisect each other. Dear students, in question number 24, the question is prove that the diagonals of a parallelogram bisect each other. So dear students, let's go to the solution. According to the question, we are given a parallelogram and the diagonals of a parallelogram. Dear students, so first we have to draw a parallelogram. So given OACB is a parallelogram. OC and AB, the diagonals OC and AB intersect at M. Dear students, according to this theorem, according to question number 24, we have to prove that the diagonals OC and AB bisect each other. That means the first diagonal OC divides the second diagonal AB into equal parts. Similarly, the second diagonal AB bisect the first diagonal OC into equal parts. Meaning of bisect each other means dividing. The first will divide the second diagonal into equal parts. The second will divide the first into two equal parts. So dear students, we have proved that OM is equal to MC and AM is equal to BM. That means the diagonal, first diagonal and second diagonal, they divide each other into equal parts. The OM is equal to MC. We have proved OM is equal to MC and AM is equal to BM. So dear students, now let's go to the proof of the theorem, vector theorem, question number 24. So in this proof, to get the proof of this theorem, at first we suppose that M is the midpoint of OC. Dear students, we suppose that M is the midpoint of OC, and then we prove that the same point M is the midpoint of AB. That means if the midpoint of first diagonal is also the midpoint of the second diagonal, then we can say that the two diagonals bisect each other. So let's suppose, at first we have to suppose let M be the midpoint. We have to suppose let M be the midpoint of the diagonal OC. Let M be the midpoint. Let M be the midpoint of the first diagonal OC, of the diagonal OC. Dear students, so if we suppose M is the midpoint of diagonal OC, then we can write OM is equal to OC. Then we can write OM is equal to MC. OM is equal to MC. So this is according to our supposition. So we can say given. Already we have supposed M as the midpoint of the first line OC. So we can write OM is equal to MC. Vector OM is equal to vector MC. Because OM and MC, they lie on the same diagonal. So the direction of OM and MC, they are in the same direction. So we can write OM is equal to MC. The vector OM is equal to MC. That means OM is equal to MC. So if any two vectors are equal, they are equal in magnitude also. So OM is equal to MC. At first we write down OM is equal to MC because we have supposed M as the midpoint of the diagonal OC. Now by supposing M as the midpoint of diagonal OC, we'll show BM is equal to MA. So dear students, now in second step, we'll express vector OM in terms of AM, and the second vector MC will express in terms of AM, because we have to suppose BM is equal to AM. So OM, the vector OM, the first vector OM will express in terms of BM, and the second vector MC will express in terms of AM, because we have to show BM is equal to AM. Next we have to show BM is equal to AM. So the two vectors OM and MC will express one in the form of BM and another in the form of MA. So let's write down vector OM at first. So vector OM we can easily express in the form of vector BM. So we'll take the triangle OBM and apply the vector addition theorem of triangle of vector addition. So dear students, so in triangle OBM, taking triangle OBM and expressing the vector OM in terms of vector BM, by using the triangle of vector addition. So vector OM we can write vector OM is equal, we can write OB plus BM. OB plus BM. So this is by triangle of vector addition. In triangle OBM, in triangle OBM, or we can say in triangle OMB. So by using the triangle of vector addition, TLBA, triangle of vector addition, we can write vector OM is equal to vector OB plus BM. So if we have to go from O to M, then by vector rule, by the triangle of vector addition, vector OM we can write as vector OB plus BM. Similarly, let's express the vector MC. The vector MC will express in terms of vector MA. So vector MC is equal to, we can write vector MC is equal to, we can write MA plus AC. MA plus vector MA plus vector MA plus vector AC. So the reason is the same, triangle of vector addition in triangle MAC, in triangle MAC. By applying the triangle of vector addition, we can get vector MC is equal to MA plus AC. Now by combining statement 1, 2 and 3, by combining the statement 1, 2 and 3, so OM, we'll put the value of OM and the value of MC, vector MC in the first statement, because OM vector and MC we have taken equal. So by combining statement 1, 2 and 3, that means vector OM and vector MC putting in the first statement. So we'll get the fourth statement. The vector OM, the value of vector OM is OB plus BM. OB plus BM. So dear students, we have put the value of vector OM in the first statement. Now vector MC, putting the value of vector MC in the first statement, then we'll get MA plus AC. So dear students, by combining statement 1, 2 and 3, we get statement 4. So this is from statement 1, 2 and 3. Now dear students, vector OB and vector AC, they are along the opposite sides of parallelogram. So we know that the vector along the opposite sides of parallelogram are equal because they have the same direction and they have the same magnitude. So vector OB and vector AC, they have got the same direction and they have got the same magnitude. That means vector OB and vector AC are equal vectors. So we can cancel them, and then we'll get vector BM is equal to vector MA. This is from statement 4. By cancelling, vector OB is equal to vector AC, because vector OB is equal to vector AC. Being vector OB and AC equal, we'll get vector BM is equal to MA. So dear students, if any two vectors are equal, their magnitude are also equal. So we can write BM is equal to MA. So we can remove the sign of direction, then the magnitude of BM and MA are equal. So if any two vectors are equal, their magnitude are also equal. So this is from statement 5. So dear students, by supposing OM is equal to MC, we have got BM is equal to MA. That means if we suppose M as the midpoint of the first diagonal OC, then we get M as the midpoint of the second diagonal also. It means the diagonals of a parallelogram bisect each other. So we are able to prove OM is equal to MC and BM is equal to MA by supposing M as the midpoint of OC. So therefore we can say the diagonals of a palm bisect each other. Hence we can write the diagonals of a palm. Hence the diagonals of a palm bisect each other. Diagonals, we can write the diagonals of a palm. Palm means it is the short form of parallelogram, bisect each other. So this is from statement 1 and statement 6. So it is from statement 1 and 6. So with the help of statement 1 and statement 6, we can say that OM is equal to MC and BM is equal to MA. That means the diagonals of a palm bisect each other. Hence it is proved. So dear students, I hope that from this video you have understood how to prove the vector theorem. Thanks for watching this video, and don't forget to subscribe our YouTube channel Karna Academy so that you get the regular updates of SE model questions, important questions. So thanks again and keep on watching. Thank you very much.